Corrosion. Have you ever observed that iron metals and things like screws, pipes and railings get rusted after a period of time if exposed to atmosphere? Have you observed a layer of rust loosely attached to the metal surface? This wasting away of metals layer by layer due to the formation of metal compounds on the surface is called corrosion. Almost all metals except the least active metals such as gold, platinum and palladium are attacked by environment and undergo corrosion. For example, when aluminium is exposed to oxygen and moisture, it forms a protective layer of aluminium oxide which prevents it from further corrosion. Copper, on exposure to humid moist air containing carbon dioxide gas for long duration, acquires a green layer of basic copper carbonate, that is CuOH whole twice CuCO3 on its surface. Silver reacts with hydrogen sulfide gas present in the air to form a protective layer of silver sulfide. Iron reacts with oxygen and moisture in air to form iron oxide, which is of reddish-brown color. This causes wastage of iron. Most of the time, corrosion is restricted to the surface of the metal. Then, how do we define process of corrosion? Corrosion is a process of eating away of a metal on its reaction with air or water present in the environment surrounding it. As a result, formation of oxide, carbonate or sulfide layer on the metal surface occurs. The oxide layer actually protects the metal underneath from the further attack of atmospheric oxygen and water. This is a protective coating that uniformly covers the whole surface of the metal. This type of corrosion is beneficial as the bulk of the metal is protected by it. Let us learn more about corrosion and rusting. Corrosion, specifically in the case of iron, is called rusting. Rusting of iron is generally caused by moisture, carbon dioxide and oxygen present in the air. Reddish-brown flakes called rust are formed. It has been observed that rusting takes place only in the presence of moist air. Rusting does not take place in dry air or in vacuum. Chemically, rust is hydrated form of ferric oxide, that is Fe2O3 XH2O, where X is a variable. In this type of corrosion, brownish oxide layer does not adhere strongly to the iron metal and can be scraped off easily, exposing fresh iron metal surface. This fresh iron surface also starts forming rust. Ultimately, rusting damages not only the surface but the whole bulk of iron. This type of corrosion is very harmful, as iron is used in all types of building structure and it is absolutely necessary to protect iron and steel from this type of corrosion. Rusting is an electrochemical process. It can be written as the equation shown on the screen. 4Fe plus 3O2 gives 2Fe2O3. This means that iron reacts with the oxygen present in the atmosphere to give ferric oxide. Factors necessary for rusting of iron reactivity of the metal. The reactivity of the metal depends upon its position in the electrochemical series. The metal which is more reactive will have a greater tendency to get corroded. Presence of air and moisture. Well, we all know by now that presence of oxygen and water will accelerate corrosion. Iron, when placed in vacuum, does not rust. Presence of electrolytes. Presence of electrolytes in water also increases the rate of corrosion. For example, corrosion of iron in seawater takes place to a larger extent than in distilled water. Strains in metals. Corrosion takes place rapidly at bends, scratches, nicks and cuts in the metal. Let us perform an activity to understand the conditions for corrosion. We take 3 test tubes A, B and C and put iron nails in each one of them. In the first test tube, we find iron nails are kept in contact with air. This test tube is covered by anhydrous calcium chloride and cotton. This means that no moisture is present in the test tube. In the second test tube, we find that iron nails are kept in boiled water which is covered by oil. In the third case, iron nails are kept in tap water and air is present above the test tube. If we observe the 3 test tubes over a period of time, we find that formation of brown colored flaky rust has taken place in the third test tube. We infer that because both the condition for rusting prevail, that is moisture as well as oxygen, that is the reason for iron nails to get rusted. Non-rusted nails are present in the first 2 test tubes. Hence, we infer that if any one of the conditions required for corrosion is removed, then corrosion does not take place. Prevention of corrosion or rusting. There are different ways in which rusting can be prevented. Rusty materials look unattractive and old. They become brittle and corrode slowly. We can prevent rusting by preventing the iron objects from coming in contact with air and water. This can be achieved by coating them with paint. Aluminium paint is painted on poles. Red oxide is painted on gates. This prevents the metals from coming directly in contact with air and moisture. Greasing and oiling also prevents the metals on getting exposed to air and moisture. A coating of coal tar can also be painted at the backside of ships. This is cheaper and long-lasting than paint. Objects coated with plastic help them to prevent rusting. Plastic cover is the preventive measure from rusting. By the method of electroplating, we can add a coating of one metal on the other. In order to prevent rusting, zinc can be coated on iron by the method of galvanization. Iron, nickel, chromium and carbon are mixed to form non-lustrous and corrosion-resistant substances by the method of alloying. An effective method for the prevention of corrosion is coating iron with a layer of zinc. Zinc is more reactive than iron. Therefore, it performs a double protective function. As an outer coating, it protects the iron against contact with oxygen and moisture, and as the more reactive of the two metals, it is the first to react with oxygen and water. As a result, the iron remains undamaged. For example, many vehicles such as cycles, motors, cars made from iron sheets are protected from rusting by paints. Many iron articles are electroplated with coating of other metals. The electroplating is carried not only for achieving brightness but also to protect from corrosion. Nickel and chromium are resistant to corrosion. Coating of these metals prevents contact with oxygen and water, protecting iron surfaces against corrosion. Besides chromium and nickel, silvery metals with a beautiful luster which gives an attractive appearance to the coated objects. However, if a coating of chromium or nickel is damaged, it loses its protective properties and has the opposite effect of accelerating corrosion. Sacrificial protection and its applications. Let us have a look at galvanic corrosion and its prevention. Corrosion in iron pipes takes place in the presence of water. In the animation which we will see now, we will have a look at things at a molecular level. Iron loses its two electrons to form ferrous iron, that is, Fe2 positive ions. The equation for this reaction is Fe gives Fe2 positive ions plus 2 electrons. The 4 electrons released from 2 atoms of iron react with oxygen and water to form hydroxide ions. These hydroxide ions react with ferrous ions to form ferric hydroxide. Ferrous ions react with hydroxide ions to give FeOH whole twice, that is, ferrous hydroxide. 4-ferrous hydroxide in turn reacts with oxygen to form rust, which can be represented as 2Fe2O3 H2O. You will observe the rust formation in the equation. This can be represented as 4FeOH whole twice reacts with O2 to give 2Fe2O3 H2O plus 2H2O. This formation of rust can be prevented by cathodic protection, where iron acts as cathode and more reactive metals act as anode. Let us take magnesium metal in this case. The reaction taking place at the anode then will be magnesium gives magnesium ions and 2 electrons. This means that magnesium releases electrons to form magnesium ions. These electrons then react with oxygen and water to form 4 hydroxide ions. In this, magnesium is used in the reaction and iron remains as it is. Let us have a look at another application of sacrificial protection. Here in this picture, we find that bars of zinc are attached to hulls of ships and oil rigs. As you all are aware of the fact that zinc is above iron in the reactivity series, so it will react and get corroded first in preference to iron. The structure will be protected from rusting as long as zinc bars remain in contact with iron structure. Zinc has to be renewed after it gets rusted.